This is lesson 3.4, Trends Across Period 3. So we also have the period 3 chlorides to look at. So we have sodium chloride to just chlorine. So as we go across from sodium chloride to chlorine, this transition from ionic to covalent actually occurs sooner than in the period 3 oxides because chlorine is less electronegative. So it forms a covalent bond with aluminum as opposed to an ionic. So as we go across, sodium chloride and magnesium chloride are both ionic, but aluminum chloride is covalent. So these two are still conductive, but this is where it starts to turn into non-conductive. And the period 3 chlorides have interesting interactions with water. So chlorine, when you add it to water, will form hydrochloric acid and bleach. So to test for chlorine gas, you are going to take blue litmus paper, and if chlorine is present, the paper will turn red because it turns red in acid. And then if you keep it in the chlorine gas, the paper will actually turn white because there's also bleach being produced. The acid-base properties of the chlorides: sodium chloride is neutral, and then all the way across it starts to get more and more acidic as you go across period 3. If you dissolve an ionic chloride in water, they will break up into ions and conduct electricity. The covalent chlorides are hydrolyzed or broken up when added to water. So when aluminum chloride is dissolved in water, it breaks up into its ions, but then the water actually congregates around the aluminum and bonds to this aluminum and forms what we call a complex ion. So actually 6 waters bond to this aluminum metal ion. And a complex ion is when you have a central atom that's surrounded by molecules or ions with lone pairs. These species with the lone pairs are called ligands, and they are attached via dative covalent bonds, meaning that they donate both electrons to the bond. And complex ions can be seen because they're always written in square brackets.